So the test is pretty straightforward for the most part. So it says, like the first few questions will say, given the parent function, write the equation. So it'll just, it's spelled, equation spelled wrong, but I typed this up really quick. So, given the parent function, you're gonna rewrite it with the shifts. So just a couple things to remember. This x squared, so our vertical stretch would be 3. So you'd rewrite f of x is equal to 3. It's going to be multiplied in front. And then your horizontal shift is left and right, 2 units left. This has got to be in parentheses x, you go opposite, right? Plus 2, and then this has got to be squared. Let me show you what I see people do, which is incorrect. That's not correct. You have to put the squared on the outside with all of that stuff. So don't make that mistake. And that's all the shifts. So we've done that. Okay, so given the parent function, write the equation. A reflection over the x-axis. So we'd rewrite f of x is equal to, it's going to be a negative. A vertical shift 3 units up. So that's a plus 3 out here, correct? Up shifts up and down, sign stays the same. And then a horizontal shift 1 unit right. So there's no stretch or compression, so you'll just have square root of, and then 1 unit right, that's plus, so you do the opposite. So x minus 1, like that, right? This is what it would look like. Pretty straight. Those ones are pretty easy if you don't make little errors. There's going to be 2 problems where you're given the picture of the graph, and then it says write the equation. So first of all, you've got to recognize what kind of function it is. So isn't this upward facing s? An upward facing s is an x cubed graph, correct? A sidewards facing s, like that's a little extreme. That's not a function. I didn't draw that very good. That's the cube root of x, right? If you see something that looks like that, that's a square root of x. And then a quadratic looks like this, x squared, right, everybody? Okay, so this is a cubic, x cubed, so that's where I'd start. I just say my parent function is f of x is equal to x cubed. Now, find a new starting point. The starting point is right before it goes up and down equally, you know what I mean? So figure out where that is. So our new starting point is left 4. So let's write it. Left 4. So then shifts left and right go opposite. They're grouped in with x. So make sure you don't start like doing weird things. So left 4, so that's x plus 4 cubed is out here, right? And then we've got to look to see if it's a stretch at all. You always check by going over 1. And then if it's up 1, there's no stretch or compression. But this one's over 1, up 1, 2, 3 units. So that is, and you have to do that from the new starting point. So that's a stretch of 3. Now notice this is increasing. Cubics are normally increasing, so it wasn't a reflection over the x-axis. So if this was decreasing, then that would be a negative in front. So that's our final answer, right? Because there was no shift up or down. Okay. So this is a what kind of function? Square root of x. That's the first thing I'd write down. It's a square root of x function, okay? Now let's find a new starting point. This is the starting point, right, of it. So it went left 5, up 3. Left. I like to write it in words. Up 3. So now let's see if there's a stretch or compression. So it's down 1, it's over 1, down 1. So there was no stretch or compression. If it was over 1, down 3, then it would be a stretch of 3, right? So that first point. So we're over 1, down 1, so there's no stretch or compression. And it's flipped upside down. So that is a negative in front, a reflection over the x, right? So let's write this out. We have f of x is equal to this negative square root of left 5, so x plus 5, and then up 3, sign stays the same. Okay, so those are the first 4 questions on the test, writing the equation. Okay, so now you're going to be sketching the graph of each function. I highly recommend you do it the way that we talked about because you will have to be exact. So this has a parent function, f of x is equal to x squared, correct? Also, you have to show some work. Because like I said, if you just type it in your calculator, that's not okay. A lot of teachers are taking their kids' calculators away for this part, but I'm not going to just give points for a correct graph. I have to see work. So then I will list out some parent points. You're using this parent function, so your x, y. So if we plug in negative 2, we get out negative 2 squared is positive 4. You plug in -1, -1 squared is 1. You plug in 0, 0 squared 0, plug in 1, you get 1, plug in 2, we get 4. That's quite a few points. You could do more, you know what I mean? The more the merrier, but that's good enough. So now we went left 1, down 2. So that's a shift left 1, so on all your x values would be shifted -1. So you'll up here just -1, and then your down 2 would be your y values, so you'd subtract 2, right? Now notice there's no stretch or compression. That's what you would take care of first. If that's a -1, multiply all your y values by -1. If that's a -3, multiply all your y values by -3. If it's a 2, multiply all your y values by 2, right? Okay, so now from here, write out your new x, y points, x, y, and this way you just, there's more likely of a chance you won't get it wrong. -2 minus 1 is -3, -1 minus 1 is -2, 0 minus 1 is -1, 1 minus 1 is 0, 2 minus 1 is 1. 4 minus 2 is 2, 1 minus 2 is -1, 0 minus 2 is -2, 1 minus 2 is -1, and 4 minus 2 is 2. Did I do that right? So if you start graphing those points and you're not seeing the it's a quadratic, right? Then go back and say, what did I mess up on over here? If your picture's not making sense, you've messed up with these. Okay, so here we go. -3 up 2, -2 down 1, -1 down 2, -0 down 1, and then over 1 up 2. So do you see how we can see these? Now here's the thing. I'm going to check because that's not that many points. Do you see how there's so much more over here that it might be? So I'm going to check one more point. So for example, I'm going to connect this, but I know it continues, but I have to be exact. So what if there's another point on here that can be plotted? Do you get what I'm saying? What if I don't have enough points? So I'd stop here and say 2. Let's plug 2 in. I'm just going to plug it in here. Or you could plug it into your parent function and then do this. Do you get what or we already did 2. Yeah, but it's shifted. It's shifted, right? So we did 2 on the parent function. So what I'm saying is on the new function, I'm just going to go plug in 2 up here. So that would be like this. 2 plus 1 squared minus 2. So isn't that 3 squared minus 2? 9 minus 2, 9, 8, 7. So do you see how if I didn't plot that point, I'd get it wrong? Because that is on the graph. So that was 2, comma, and this was in this function, not the parent function. 2, comma, 7 was a point on our graph. Over 2 up 7. So then we're going to be over here symmetrically, right? Because that was over 1 more up 1, 2, 3, 4, 5, right? So we're going to be over 1 up 1, 2, 3, 4, 5. So I would have to have plotted all of those points to get it right. So also from the beginning, I could have just done -3, and you know what I mean? I could have done more points, but you get what I'm saying? Everybody knows confused? Okay, cool. Next one, sketch the graph. So you'd say, okay, this is a parent function, f of x is equal to the square root of x. Let's make plenty and plenty of x, y points here. If we start with -1, we have I, so that's why we know we don't start with -1. Plug in 0, we get out 0. Plug in 1, we get 1. Plug in 2, square root of 2 is a decimal. Plug in 3, square root of 3 is a decimal. 4, square root of 4 is 2. Then 9 is next, isn't it? We get 3, 16 is next, we get 4, 25 is next, we get 5. That's tons of points, but I'd rather be safe than sorry. So now we're doing a stretch of 4, so we've got to do that first. Take all your y values and always multiply by that first. So let's times by 4. Let's write down those, and then we're going down 5 after that. So that's another shift on y, correct? So let's do this one first. So I'm going to write that out. 0 times 4 is 4. 1 times, not 4, 0. So don't do that on the test. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. Those are getting pretty big, so I'm going to just stop there. Does everybody get what I'm saying? And now we're subtracting 5. So from y values, because it's a downshift of 5, right? So y shift. So subtract 5 from that, and we get -5. Subtract 5 from that, and we get -1, right? Subtract 5, we get 3. Subtract 5, we get, subtract 5. Okay, perfect. All right, let's plot those points. Over 0, down 5. We just plotted that point. Over 1, down 1. Over 4, up 3. And then over 9, so that one doesn't fit on my graph. So I can stop, but if it did, I'd just go plot that. So now look, I'm going to connect it because I know what a square root function looks like, and we're all good. Okay, questions on that? Okay, those are 2 questions on the test. Okay, next part of the test, we'll actually have you compare some domains and ranges, which I don't have an example up here. So if I said to you, compare this function's domain and range to this function's domain and range, wouldn't you just write out the domain and range of the one function, write it out of the other, and then compare them and say, oh, this domain is the same as this domain, but this domain is different, or whatnot. You get what I'm saying? Just think logically. So if I say to you, find the domain and range, draw a rough sketch of the picture, and then say domain and range, right? Okay, so next part of the test after that is given a piecewise function, find these values. So remember, a piecewise function just is one function that contains multiple other functions. And this is our function for x values that are less than or equal to 1. This is our function for x values between 1 and 3. This is our function for x values larger than 3. So it says, find the function at 1. So if we plug 1 in up here, f of 1, which one is it going to go into? Which interval is that x value? 1. That one, right? So what is the function? At 1, 2, right? There's no calculating involved. Does everybody see? Okay, so we'd say 2. What's the function at 2? So we're plugging in 2. So we plug it in here, here, or here. 2 is between 1 and 3, isn't it? So that means we're going to plug it in up here. So you would go like this to show your work. 2 squared minus 3. That's 4 minus 3, which is 1. Okay, f of 5. That means we're plugging in 5. We're putting 5 in here. So does it plug in there, there, or there? X is greater than 3 because 5 is greater than 3. So you would show your work by going 4 times 5 plus 1. So square root of 25, 26, right? Yeah, it's 21, not 26. 4 times 5 is 20, plus 1 is 21. That would be our answer. Does everybody see how you just plug it into the appropriate spot and you're done? Okay, awesome. That's all you're going to be asked to do. Don't miss those ones. Okay, next part of the test, we'll say graph. There's actually 2 graphing of piecewise functions, but they're actually really pretty straightforward ones. There's no tricky ones. So you have to be able to graph that correctly, something like that. So x cubed minus 2. So that's a cubic that looks like, cubics look like this, right? Okay, so it was shifted down 2. And then you could just plug in points as well, right? You could go off to the side, go x, y, plug in 1, and you could even just plug it in here, right? 1 cubed is 1, 1 minus 2 is negative 1, right? We plugged in 1 and got out negative 1. Do you see what I'm saying, everybody? Okay, so I know that the cubic works like this, but you could plug in 2. 2 to the 3rd power is 8. 8 minus 2 is 7. No, it's not. It's 6. So I messed up. I just didn't start at the right place. So we plugged in 2 and got out 6. So anyways, and then somewhere down here. So we have this looking graph here. And now we're only keeping it for x values less than 1. So that's when you'll go to 1, find where your function is at, right? X value is below 1. So I'm going to erase above. You see how I stopped there? Okay, now does it include 1 is the question? No, right? So we go over to 1, go to the function, and open it up so that I can make sure I see that open circle. Okay, moving on to this now. Ignore that previous function. Now we're graphing absolute values. You have to remember that these are v's. Looking at this, is there any shift left or right, any shift up or down? No. So that means we're starting at 0, 0, right? This is a slope of 2. V's have slopes. Up 2 over 1, it's up 2 over 1, it's a V. Up 2 over 1, up 2 over 1, up 2 over 1. Let's do it on both sides. Okay, so if I drew in that full V, that would be good. And now we're keeping that for x values greater than or equal to 1. So I'm going to go to 1, right there. So we're erasing below 1. It's or equal to 1, so I go over to 1, go up to here, close it off. Your functions will all make sense. Look, this one starts over this way, then there's an open circle at 1. Then this one is closed at 1 and continuing. So if you have 2 closed circles, then you forgot something. If you have 2 opens, you know what I mean? Look back at it. These will be functions all on the test. It will be nice and pretty. Okay, cool. Next one, graph the function is also a piecewise function. Look, x squared plus 2. So you'd say, oh, that's a parabola. This one shifted up 2. So I go up 2, correct? You could just plot points. Let's plug in 1. 1 squared is 1. 1 plus 2 is 3. So over 1 up 3. Let's plug in 3. 2. Let's plug in 2. 2 squared is 4. 4 plus 2 is 6. So same thing over here. So now we're graphing our quadratic. And then we're keeping it for x values less than or equal to 0. Less than. So that's below, right? So I'm going to erase above 0. That's x is 0, right? Not y. Okay? And it includes 0, so I'll keep it close. Let's move on to this one. You would say this is a square root function that looks like this, but it's been shifted down 1. Go down 1, and then just plot points. So plug in 1. Square root of 1 minus 1 is 0, right? Plug in 2. Square root of 2 minus 1 is a decimal. Let's not do 2. Let's plug in 3. Square root of 3 minus 1 is a decimal, right? Square root of 4, which is 2. 2 minus 1 is, so it was 4 up 1, right? So it looks like this. Now we're keeping it for x values greater than 0, so that's all of it, right? But not including 0. So right there, I just make sure it's open. Okay. So they are going to be really straightforward. Like that wasn't really tricky, right? Just be careful. And then once again, look from left to right. It is a function. Everything makes sense here. Okay, next part of the test, we'll say simplify. You won't have to put in absolute values on this. I'm just saying simplify. So as long as we can simplify correctly, 40 is 4 times 10. 10 is 5 and 2. 4 is 2 and 2. We're pulling out group sub 2, correct? So we'll pull out a 2. This has got to stay. This has got to stay, right? So I'm going to go off, put a square root, and we have a 10 underneath. I'm leaving some room here. Okay, I've taken care of all that. 4 divided by 2 is x squared, right? Nothing left underneath. Y to the 5th is 1, 2, 3, 4, 5. So when we pull out y squared, left is a y. And next problem. Simplifying this, do not say I. I still have people saying i's. Odd roots, if they have negatives, just have negative answers, right? Got to pull out the negative. So negative 2, 3 divided by 3 is a to the 1, yep. And then 12 divided by 3 is b to the 4th. And nothing was left into the radical for that one. Simplify. So if you're dividing square roots or cube roots or any roots, you should put them together first. So square root of 20x squared y to the 4th divided by 80 x to the 4th y squared. Then you simplify what's under the radical. 20 divided by 80 is 4, right? Yeah, 1/4. Good. I like they said 1/4. So I'm going to put 4 on bottom. Then x squared and x to the 4th would be x squared on bottom, right? Y to the 4th and y squared would be y squared on top. Now split it up. We have the square root of y squared divided by the square root of 4x squared. So now doesn't the top become a y? The bottom becomes a 2x. So there was no rationalization needed. Because if we simplify it like that, then we're doing it the smart way and not the hard way. Okay. Something like this, simplify. When adding these things, we have to have like base and like radical, right? But we don't know if they're like or not without simplifying. So 5 and 10, 5 and 2. So pull out a 5. Don't make the mistake of saying 25 or, you know what I mean? So pull out a 5. So we have 5 root 2 minus 6 root 2, which is how many root 2s? Negative 1 root 2s, right, everybody? So that would be our answer. Okay, simplify. There's a radical on bottom. There's 2 terms. So to fix it, we multiply by the conjugate. 1 minus root 3. 1 minus root 3. Here's the thing. We've got to be putting parentheses around things with 2 terms. That's what I see people still missing. Negative 4 times 1 is negative 4. Negative 4 times negative root 3 is positive 4 root 3s, right? Now we can't combine those because they're not alike. On bottom, 1 times 1 is 1, minus root 3, plus root 3, minus root 9. So that becomes 1 minus 3, correct? 1 minus 3, which is negative 2, right? So I'm going to erase that and write negative 2, and then we're going to look at it and see if we can simplify. Negative 2 is what that bottom simplified to be. 4, 4, and 2. They all three divide by 2, correct? So won't we divide all of them by 2? So negative 4 divided by negative 2 is positive 2. Positive 4 divided by negative 2 is negative 2, and then we still have root 3. Only if all three of them divide can you do it. You can never just do those two or those two. If that's the case, leave it. If that would have been this, if this would have been our answer, you would have left it. Okay? All right, so this was our answer for that. Okay, the difference between that problem and that problem is this radical doesn't simplify still, but we have a radical in bottom, but it doesn't have two terms, right? So we would multiply by, well, we're not going to do the cube root of 4 times 4, because then we're going to have to simplify it. Remember, the first thing we need to be checking is, can I rewrite 4 as anything else? 2 times 2, right? So we'll multiply by cube root of 1 more 2. Cube root of 1 more 2. Now notice, there's two terms. We've got to start putting parentheses around two terms. Cube root of 2 times cube root of 3 is cube root of 6. Cube root of 2 times positive 1 is positive cube root of 2. Can we combine those? No, no, right? To add them, they have to be like bases as well. Now on bottom, we have the cube root of 2 cubed. 1, 2, 3 2s, right? So root cancels out with power. So we have a 2 on bottom. Okay. Good. Okay, simplify. So this is multiplication, correct? So don't we just reorder it? X to the negative 3 times x to the 1/2. Even though there's parentheses there, it doesn't mean it's connected. It looks like it's connected, but it's not. Times y to the first. That's so important, right? Then when you multiply, you add, right? So we would do negative 3 plus 1/2. Math, enter, enter. Will somebody do that? And then when you multiply, you add. This one's negative 5/2. And then negative 3/2 plus 1. Negative 1/2. Is that right? Okay, perfect. Is that our acceptable final answer? No, because we can't have negative exponents in our final answer, right? So the last step is literally flip anything with a negative exponent over a fraction. So both of them need to be flipped. What's left on top? So we have 1 over x to the 5/2, y to the 1/2. And we are not going to rewrite that as a radical because didn't we start with exponents that are fractions? So you can end with exponents that are fractions. So we're done. So what if we would have ended up with this as our answer? X squared y to the negative 3/2. The only one we flip is that one, right? Okay. Next one, you're going to ask me asked to find FOG and GOF. So given function f and function g, let's do FOG. You've got to do it in the correct order. So squish x back in with g, that's g of x, right? Squish it back in again, that's f of g of x. So this one we should be plugging in g of x. So you can go circle g of x and plugging it into function f wherever there's an x. Replacing it, right? So that's 2 instead of an x, we'll have 3x squared plus 1. Do not forget minus 3. That's what people were forgetting on the last test we just took. They forget that minus 3. Does that make sense, everybody? Now we'll simplify it. We're not solving it though. There's nothing about solving here. There's no equal sign. So when we distribute that, 6x squared plus 2 minus 3, right? So that's 6x squared minus 1. And you're done. You don't need to solve. You don't need to do anything else. Okay, let's do the other way around. X back in with f. That's f of x. Squish it back in with g. G of f of x. So we should be substituting in f of x. So here's the catch, guys. Look. We're substituting that into the other function wherever there's an x. If there was an x right there, you'd need to put it in both places, right? Okay, so we would have 3 times, instead of x, we're putting that, 2x minus 3 squared, and then plus 1. Is it appropriate to put 3 in first and then square it? No, because 3 isn't squared. If you do that, you'll be squaring 3. So this one would need to keep going like this. We'd say 3 times Let's focus on multiplying that out. 2x minus 3 times 2x minus 3, and then plus 1. So let's distribute that. 4x squared, right? Minus 6x minus 6x, and then plus 9, right? Combine like terms. 4x squared minus 12x plus 9. Now it was 3 times all of that, but not that, right? Is everybody following me? Plus 1. So now we would multiply 3 in, so that's 12x squared minus 36x plus 27 plus 1. 12x squared minus 36x plus 28. So quite the simplification, but you can do it. Okay. Okay, next one, it says find the inverse of each function is the inverse of function. So we would switch x and y. So we have x is equal to 2y squared plus 3. We'd subtract 3. X minus 3 equals 2y squared, right? Divide by 2. X minus 3 divided by 2 equals y squared. Then we'll square root both sides, correct? What did I forget? The plus or minus, correct? It's a full quadratic, so you need the plus and minus. This would be an acceptable answer on a regular level. If you want to go further and do the honors level, then that's great, by rationalizing the denominator, right? If you stop there, though, it's okay, it's right. But I do want some of you, because I know some of you could be in honors, I'm going to be like, oh, why didn't you go a little further? Does that make sense? I wouldn't mark it wrong, but I'll be like bummed if some of you don't go further. Yes, it would be this. So this, you would rewrite it as right square root of x minus 3 over square root of 2. You multiply by square root of 2 over square root of 2. So that would be square root of 2 times x minus 3 in parentheses, right? All over 2. So like you said, Luis, 1/2 square root of 2 x minus 3. That would be the advanced answer. If you stop there, though, I'll mark you right. So now it says, what's the function's domain and range? So the original function is a quadratic. Draw yourself a rough sketch. So you have to say to yourself, okay, this is a quadratic that's been shifted up 3 units, correct? And then there's no shift left or right. So anyways, we go like this. A rough sketch is good for domain and range. Our domain for the original function is all real numbers, right? A quadratic. So what's the range over here? All real numbers. What's the range of a quadratic? 3 to infinity, right? 3 to infinity. So our domain is 3 to infinity on our inverse. Okay, so find the inverse of each function. So we switch x and y. 4y minus 2 over 3. First step is multiply both sides by 3. 3x equals 4y minus 2, so we'd add 2. 3x plus 2 equals 4. That's a 4, and this is a y. Okay, divide by 4. Now, I won't mark it wrong if you left it like that, but that's hideous. Really, most of you should be pushing yourselves to write it right. This is still a line, so isn't that 3/4 x, like this? 3/4 x, and then what's 2 divided by 4? 1/2, so plus 1/2. In fact, people that stop there, I might mark them off like half a point and score 3. I might mark off them a little bit, just because I've been pushing you to go this far. You know what I mean? So I want to reward those that do go that far. Okay, so our function, the domain is, it's a line, guys, right? Looking at this, do you see how this isn't even written pretty? So isn't that 4/3 x minus 2/3? So it's a line. So what's the domain and range of a line? All real numbers, guys. Lines grow forever up and down, side and side, right? So then these are all real numbers. Okay. Graph the function at its inverse. This is almost to the end of the test here. So you'll graph the original function. Take my suggestion here. So this is a line. That's when our y-intercept's -3, right? Our slope is 2. So you go, it's +2, up 2 over 1, 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 down 2 over 1, down 2 over 1. Hey, I'm going to remind you of something. You could actually go through and find the other line and graph that, or couldn't you just take all these x, y points and switch x and y? Do you get what I'm saying? Remember that in inverse, the x, y points are just switched. So that's almost easier than graphing. Some of these lines don't come out very pretty, like they're decimals. Does that make sense? Like plotting, going up 1/3 and then up 1 over 2, and that's kind of hard one. Does that make sense? So looking at this point, let's start here. This is over 0, -3. We could write out your original x, y points. 0, -3, right? And then, so then our inverse will be negative 3, 0. But I'm going to write probably all out my xy points and then swap them and then graph them. So our inverse of that would be negative 3, 0. So it's going to end up looking, anyways, it's hard for me to see it without actually talking. Do you get what I'm saying, everybody? We just don't have very much time left. Are you sure? And then this is what it should look like. Remember that if you draw in a dotted line for y equals x, you gotta make sure you draw that in, right? This dotted line, those points should match evenly over, right? So you see how this point and this point match evenly over? So there's gonna be an inverse right here for that point, right? And then like right there for that one, right? Do you get what I'm saying, everybody? So you can kind of make sure your inverse looks good. So it's going to look something like that. It's going to be that. That will be that point. That will be. So our inverse is going to turn out looking something like that. You see how they match up? Okay, good. Okay, so graph the function and its inverse. So this is a quadratic that's been shifted left one, down one, right? And then our stretch is 2. So you can plot. You guys know how to draw graph these. Anyways, you can plot points, then you can switch those xy points and plot the inverse. Do you get what I'm saying? It's almost easier just to do it that way for this type of thing. So you have these xy points, that full quadratic. So when we switch those xy points, this is -1, -1, right? So when you switch that, -1, -1, it will end up there. This is over 0 up 1, so then won't it be over 1 up 0? This is -2 up 1, so now it'll be over 1 down 2. So do you see how this one's going to end up looking, the inverse will look like that? Which was not a function, right? Everybody? Okay. So it says, describe the shift from the parent function. So we would say left 1, down 2. Is that easy? This one we would say down 4, stretch the 3, reflection over the x, right? What about this one? We would say compression of 4, and that's it, right? No shift left or right, no shift up or down. Okay. Left 3, down 2, compression of 1/2, reflection over the x-axis. What's the problem with this one? The 4, correct? So we pull out a 4, divide by 4, divide by 4, left, oh, that wasn't, look what I just did. Almost made a mistake, because that's under the radical. We pull out a 4, left is x plus 1/2, right? Minus 3. Square root of 4 is 2. 2 square roots of x plus 1/2 minus 3. So we would say left 1/2, down 3, stretch a 2. So watch out for the values in front of x that are not there. Okay, this is the last problem on the test. It says find, given the function f and g, find f divided by g or g divided by f and state the domain. So f divided by g, x squared minus 3x is f, divided by 9x minus 27. That is not my final answer because doesn't it simplify? On top we'll factor out an x, left will be x minus 3. On bottom we'll factor out a 9, left is x minus 3, correct? Now before we divide anything out, we've got to restrict the domain. So x cannot be 3 because we can't divide by 0. So that 9 is okay because there's no variable. Now we'll divide out. So our final answer would be x over 9. Our domain was all real numbers except for x can't be 3. And that's the last problem on the test. So pretty straightforward test as you can see. No tricks, it's straightforward everything we've learned. Okay, that's it. You should do good, especially now that you came.